Postgres is claiming that it is an RDBMS database technology. When some database is claiming that it is an RDBMS database technology, it has to satisfy two things. One, it should be SQL compliance. Two, it should be ACID compliance. If a product is claiming that it is an RDBMS technology, it should satisfy one, SQL, two, ACID properties. When I say SQL, SQL is a universal language that you use to communicate with your database. That means select star from employee is a query that you write to fetch information from your table. This is an independent thing. So if you are claiming that you are an RDBMS product, this query should work. Postgres is claiming that it is an RDBMS. That means when I run the query, it should work. Oracle is also claiming that it is an RDBMS. That means when you run the same query with the same syntax in Oracle, it should work, provided that employee table must be there. Second is it should be ACID compliance. That means it should satisfy ACID properties. A stands for atomicity, consistency, isolation, durability. A stands for atomicity, C stands for consistency, I stands for isolation, D stands for durability. It's an acronym. Any questions so far? Okay. What atomicity property says, irrespective of number of transactions in your statement, treat them as unique. Irrespective of number of statements in your transaction, treat them as unique. So this is the property of your atomicity. For example, if you are sending some, let's say 500 rupees to your friend, what happens in the backend? You have opened your bank account and sent some 500 rupees to your friend, or you purchase something from Amazon. So this thing should happen. One, update employee set salary equals to salary minus 500 or 100, where ID equals to 1. From your account, 100 should be deducted, and from your and to your friend's account, 100 should be credited. So if I'm sending 500 rupees to my friend, these are the statements that get executed in the backend. What atomicity says, irrespective of number of statements in your transaction. I have two statements here, 1 and 2. Treat them as unique. That means either you execute both or you execute none, but it should not be like first executed successfully and second failed. We'll understand that in a moment. Again, consistency says there is no specific definition for consistency. It simply means if your database is satisfying atomicity, it is consistent. Simple. For example, I'll come here. I have, let us say, 500 rupees. My friend account has, let us say, 200 rupees. I'm sending 100 rupees to my friend. After successful execution, amount will be deducted from my account. It will become 400 and credited in my friend's account. It will become 300. This is a successful uh, transaction. What happens if the first is executed successfully and second is failed? Amount got deducted from my account, but it has not credited in my friend's account. This is a failure transaction. First executed successfully, but second failed. Atomicity, what it says, treat them as unique, which means either execute both or execute none. If the first executed successfully and second failed, you have to roll back your first. That is what atomicity says. That means for some reason, execution of second one failed. If that is the case, you roll back your first. That means bring your money back. That is why you get your money back when your transaction is failed, when you're doing online transactions. Sometimes amount get deducted from your account. For some reason, if it is not credited in your friend's account or in Amazon, Swiggy, whatever it is, within few minutes you'll get your money back. It will roll back your statement one if the statement two fails. Is this clear?
Yes, Kumar.
Okay. Now see here. This is before doing transaction. What is 5 plus 2? 700. After successful transaction, 4 plus 3, 700. After failure transaction, 4 plus 2, 600. That means before and after my transaction, 700, 700 matching. But before and after transaction, 700, 600 not matching. Consistency means before and after your transaction, your database should be consistent. There should not be any discrepancy. You can also understand in that way. So it should be either consistent. I mean, the definition can be you can understand like it should be consistent before and after your transaction, or if your database is satisfying atomicity, it is consistent. What atomicity says, irrespective of number of statements in your transaction, treat them as unique. And these two we are discussing in terms of ACID, but not in terms of Postgres. It's a generic term. What atomicity, what consistency, and all that stuff. Reads and writes should not interfere each other. And reads should always see consistent past image. So this is your isolation property. Reads and writes should not interfere each other, and reads should always see consistent past image. When you are reading something, when you are writing something, you can read the data and vice versa. That is your isolation property. We'll see an example in a moment. What durability says, at any cost, my data should be safe. This is your durability. Yeah. Um, just to recap, um, atomicity, irrespective of number of statements, treat them as unique. In your transaction, yeah, treat them as unique. Consistency, if your database is satisfying atomicity, it should be consistent. No specific definition for that. Then isolation, reads and writes should not interfere each other. Durability, at any cost, metadata should be safe. Now, how Postgres achieves all these things? One, atomicity. Postgres achieves atomicity with the concept of begin and end. For example, I'll come here, insert into employee values 2, 200. Yeah, I'll put begin. That means you are marking the start of the transaction. Then what you do? Update employee, set salary equals to, let's say 200, where ID equals to 1. I have updated employee 1 salary. Then salary equals to, let's say 300, where ID equals to 2. Then you put end. Here I executed 2 statements. And then I kept end. In Postgres, when you run your begin, it marks the start of the transaction. You will see star here. That means you are in the transaction mode. When you do statement 1, for some reason your statement 2 is failed, I'll issue commit, end, it should roll back. This means your transaction is failed or your statement is failed. I will not continue or I will not commit your statement 1. 1 second. Again, come here. I'll do begin. Execute your statement 1. What happened? Okay. Begin. I'll do my statement 1. I'll do my statement 2. I will put commit. So either you can use commit or you can use end. Both are same. You can also use begin, write your statement, roll back. That means you intentionally wanted to roll it back. You don't want to execute this statement. Your Postgres achieves atomicity with the concept of begin and end. Irrespective of number of statements in begin and end, Postgres treats them as unique. If the second one fails, it automatically rollbacks the first one. I'll do begin, not begin. Let me check the salary, both are 300. I'll do something like this. Update employee, set salary equals to, let us say 500, where ID equals to 1. Now what I'll do commit. What it says, there is no transaction in progress. Which means if you are not putting begin and end, Postgres treats every every statement as a transaction. I'll remove this. If it's not enclosed in begin and end. Very, very important thing. You're asked to update phone number for a certain employee. What you'll do something like this. Update employee, set phone number equals to whatever the phone number, and you have to write something like where account number equals to the account number who has requested to change the phone number. If you forget this where condition, it will update the phone number to each and every record. You cannot roll it back if you are not putting that in begin and end. So it is always recommended to follow this begin and end. Any questions here?
Yeah, Kumar.
Go ahead.
Rollback means it will replace the transaction.
Correct. Rollback means it will take your table to wherever it was before you start your transaction. Something like this. I'll put something like select star from employee where ID equals to 1. Currently, my salary is 500. What I'll do, I will put something like update employee set salary equals to, let's say 1000, where ID equals to 1. I changed my salary to 1000 rupees, but I don't want it. I change my mind. I'll put rollback. Then run the command, select star from employee where ID equals to 1. You have your 500. Instead of rollback, when you put commit, that means you're confirming the change. That means you're okay to change this. Again, if you're not okay to change this, why you're executing it, why you're rolling it back, you will not roll back mostly. The system will roll back if the second statement fails. That is what I'm telling, right? You change your statement 1. That means amount got deducted from your account and it should be credited in your friend's account, right? So if for some reason, if it is not credited in your friend's account, it will roll back automatically your first statement. We are manually doing it. Sometimes what happens, your developer will write a query and will ask you to execute it. Now you execute it and you have something like update 1. That means 1 record updated. You have to tell the number to the developer. See, after executing your query, let's say 47 records got updated. Are you sure you want me to continue? If they say, yeah, continue, you have to commit. Otherwise, you have to roll it back. There might be some issue with the statement. Is this clear?
Just one more question.
Mhm.
When you do an update, say where ID equal to 1, is it locking the entire table or just that row with ID equal to 1?
That particular row only, exclusive lock.
That row only. Okay,
Mhm.
exclusive lock. Got it. Thank you.
Row exclusive. Right. As I said, no, there is no specific definition for what do you call consistency. I'll go to isolation. What isolation says, reads and writes should not interfere each other, and reads should only see the consistent past image. Root RSE123, switch to Postgres, and I'll do Postgres. Right. If I'm executing some command, and if I'm not telling that to you, which means that is not required for you at the moment. It will either come back later or it is not at all required to you. Remember that. Right. I'll do something like this. Select star from employee where ID equals to 1. Salary is 500 rupees. Now what I'll do booking. Update employee, set salary equals to 1000. Let's say 600. Where ID equals to 1. I have updated the salary to 600, but I have not taken any decision. I wanted to confirm or not. I have not taken the decision. Now what I'll do, I'll try to fetch the same information from second session. I got 500. That means I got this information. I'll try to get the information from within the session. I got 600. So the session where you're executing update will see the latest information, or any other session will see its consistent past image. So whatever that is being executed, you cannot see that from other sessions. Only that particular session can see that. I'll do commit. Then you can see 600 because it is now committed. Let's say you have 500, or else I'll put something like this. Yes, oh, sorry. Yeah, I'll do select statement. My salary is 100 rupees currently. 1 comma 100. Then what I'll do, I'll begin. I'll do something like update employee, set salary equals to 200, where ID equals to 1. When you execute this statement, what happens behind the scenes is it will take the copy of that record within the table 1 comma 100, and this copy is for selects. By other sessions, select star from employee where ID equals to 1. You see this 100 from here, and it will change this to 200. At the moment, you have a version 200, a version 100 of the same record. Postgres achieves isolation with the concept of MVCC. MVCC means multi-version concurrency control. Postgres will have two or more versions of the same record in the database when you are doing a transaction. So the first version is for selects. This version is for update that is happening in that particular session. So you have two versions or multi-version of the same record for the concurrent access. So it is controlled with this kind of mechanism. What is multi-version concurrency control? Multi-version concurrency control is a mechanism that helps Postgres to achieve concurrent access. It will have two versions of the same record within the table to satisfy isolation. I'll again recap. Let me get the current employee details. 1,100. 1,100. As soon as I issue, what is this? As soon as I issue update, it takes the copy of that record within the table, and then it will update this 200. It will put a star mark here, which means that is hidden. And any select will see this. As soon as I commit, this star mark will go away. This is marked as dead. Now your selects should see this. Again begin. I'll update it to, let's say, 300. I don't commit at the moment. I'll come here and see. I should see 200 because that is the consistent past image. Then I'll try to update here. $400. It should not work. Why it is not working? Because I have not taken any decision here, which means that record is logged. Reads and writes should not interfere each other, but writes and writes should interfere each other. They will interfere. You are writing it from the session 1 and you wanted to write from the session 2, it will not work. When it will work? When I commit this. I'll try to commit. It's done. Any question on isolation?
And also, can you give the example with a rollback also? Once again.
Where rollback?
Instead
This is the
of
rollback.
commit.
Where here?
Oh, yeah.
Simple. You do begin. Sorry. You do begin. What is my current salary? My current salary is 400. I'll try to update it to, let us say, 500. Here I'll try to select. It is 400 because the consistent past image. Now I will update it to, let us say here, 600. It will not work. Currently, my salary is 500. Uncommitted salary is 500. Committed is 400. Now what I'll do, I'll roll back this. When you roll back this, that means you are releasing the lock. When I released the lock, this statement got executed. What is this latest one? 600. Now the salary should be 600. You release the lock either with statement commit or end or rollback. Any other questions? Are you understanding first thing first? Understood? Yes, no, maybe.
Yes, sir.
Last thing is durability. Postgres achieves durability with the concept of wall files. That means every transaction you make is recorded in a file called wall file. I'll go to user1 pgsql 17. This is the location where I have my database files. Inside that you have a folder called pg_wall. Inside that you have your wall files. This is your wall file. So every transaction you do is recorded in this file, and as long as this file is there, your database is safe. That is what your Postgres says. As long as your wall file is there, I will recover your data. So yeah, at any cost means you should have your wall files. That is the first thing. If you retain your wall files, your data is always safe. Understanding how your wall files helps in recovery, it's a very big thing that we'll see after, let's say, 15-20 days. Postgres achieves atomicity with the help of begin and end. Postgres achieves consistency with the help of multi-version concurrency control. Postgres achieves durability with the help of wall files. Any questions? That's it about ACID properties. Yeah. If you have no questions, I will jump to next topic. Okay. The next is setting up your environment. What I'll do, I'll stop this. Where it is there? It is there in D lab 10 lab 01.